What's up, everybody? Ladies and gentlemen, boys and girls, is everybody all right? I just need to know in the live chat. And am I audible and visible properly? Come on, all of you in the live chat itself. Yes, we are live. So, what's up, everybody? This is me, Yawar Manzoor, and I believe everybody of you is doing great, nice, and absolutely fine. And today we're gonna be talking about the relative motion, everything. What is this relative velocity? What is frame of reference? What is relative displacement? What is relative acceleration? What is this rain man problems? Okay, and what are these river swimmer problems, river boat problems, some of the previous year questions, everything we're going to be talking about by today itself. Okay, so all of you, I just need to know in the live chat if you can hear me and if you can see me properly. Come on, all of you, do let me know in the live chat. Drop a thumbs up, whatever, drop a heart, whatever you want to send. Exactly. Okay, yes, then we'll get started accordingly. Yeah, what's up? So let's get started basically. And this is a piece of information about me. You can definitely read it out from the screen itself. My name is Yawar Manzoor and I'm from Kashmir exactly. And yes, I'm good. And this is a piece of information. I have 4+ years of experience in JEE. Okay. And apart from this YouTube platform, we have our own platform. That's what we call the Unacademy's platform. Okay. And over there, if you take this plus subscription on our Unacademy's platform, you'll be getting so many benefits because there are so many educators who are teaching you inside Unacademy itself. Okay. So you'll be getting live classes, weekly tests, structured courses, unlimited access. Okay. Everything you will get over there. And if you take this iconic subscription, you will be getting all of the benefits you get in plus, and there are some other benefits as well, like you'll be getting personal guidance. Personal guidance means you'll be getting an educator. He'll be guiding you throughout your exam. If you need any sort of assistance, if you have any sort of doubts, or if you need any sort of clarifications, he'll definitely help you throughout your exam till you crack your JEE. Yeah. And in this iconic subscription, you will be getting basically a test analysis. Once you are done with your test, once you give the mock test, weekly test, after that your scores will be basically analyzed, that in what portion you are lagging, in what portion you are supposed to work more. Understand? So that's what we call the analysis. This is done in iconic subscription. And experts guidelines, if you want to crack any of the competitive exam, you have to definitely take the tips, tricks, and follow the different guidelines from different JEE experts that you'll be getting in the iconic subscription. And definitely the branded notes will be sent to you. That's the study material and the study planners. Okay. Okay. Good evening. So is everybody doing great? Come on. And this is my username on Unacademy. You can definitely follow me over there. This is my username, Yawar Manzoor, because we come up with so many special classes every single time. That's completely for free. So you can join us over there as well. And people were saying previously that there are no batches which are completely in English in Unacademy Plus, okay, or on Unacademy Plus. So people, we have recently launched the batch that we call the Spark batch on Unacademy Plus. This is completely in English language. And over here, there are some of the top educators from different states who are teaching you inside these batches. So this is for 11th class JEE Mains and Advanced 2023. So you can definitely enroll in this batch right now, right here, okay? And this is what we call the Shine batch. This is for JEE Mains and Advanced 2022. You can definitely enroll in this one because some of the top Telugu educators who are teaching you over there. So you can definitely go over there and if you want to boost your rank in your upcoming JEE. Now the point is, okay, how you can enroll in our special classes. Because special classes are completely free, like you watch our lectures on YouTube, same is the case, but you have to come to Unacademy on Unacademy app, and how you can enroll in our special classes, how you can come in our special classes. I'll just tell you the process. So you just have to download the Unacademy app. Over there, you'll be getting the interface like this. Once you sign up, log in with your phone number. Afterwards, you have to search my name. This is my name, Yawar Manzoor. Okay, this is my username on Unacademy, and you will find my profile something like this. Okay, once you click all over here, there are so many special classes. You can watch the recorded one as well. Okay, so you can basically enter in any of my class, and over there you will find the interface something like this. Once you click on this class over here on this play button, and it'll ask you for a code. You can definitely use this code in order to watch any of my special classes, or in order to join our live special classes as well. This is completely for free. Okay, now if you take this IIT JEE Iconic subscription, you'll be getting the branded notes, but you have to take it for 12 months, 18 months and 24 months. And to take this plus subscription also, so you'll be getting 2 months of extension for free. Okay, that's great. And if you take this plus subscription, if you take this Iconic plus subscription for 18 months, 24 months and 12 months, the prices are basically mentioned over here. And even you can take this plus subscription for 3 months and 6 months as well. Even EMI options are available, you can understand. So by using my code, if you want the maximum possible discount from this price itself, so you have to use my code. Understand, you'll be getting the maximum possible discount. This is my code, you can definitely use it. Now you can take this subscription, Iconic subscription for 12 months, 18 months and 24 months. The prices are mentioned over here. If you want the maximum possible discount, definitely I suggest you to use my code. This is my code. Okay, yeah, that's great. And moving on to, we have this IIT JEE Mega Combat Scholarship Test. This happens every Sundays. Okay, if you wanna basically learn free on Unacademy, if you wanna grab the scholarship of more than 4 crore rupees, you should definitely enroll in this one. So basically this is a test. In this test, there will be 21 questions and 60 minutes will be given to you. You have to give that test. If you get the ranks accordingly, you'll be getting the prizes like this. Okay, and most importantly, this is one of the beautiful things that are happening inside Unacademy right now. What is that? That is the top educators are solving the JEE mains papers, 4th attempt papers, which is going on right now, and they are solving it inside Unacademy for free. You just have to click on the link that's given in the description below. You can basically go over there and you can come in these special classes where they solve the papers. It has already started from yesterday itself, so it will go. You can check that out, the dates and everything. And if you find any of my content as inappropriate, you can definitely report. The link is in the description below. Everybody, shall we start? All of you. We'll basically start with the relative motion itself. I just need to know in the live chat if everybody is feeling excited today. Come on, all of you in the live chat, then we'll start accordingly. Drop a thumbs up, whatever you want to send me, give me this signal, then we'll move, then we'll start. Yo. Okay. Yeah, excited. Okay, this is the portion from Kinematics in which most of the time questions are asked in JEE mains in advance. Okay, so you have to make this portion very strong. So I suggest you to stay with me for the next 1.5 hours. We'll complete this in just 1.5 hours, entire relative motion. And most importantly, once we get done with this, tomorrow at 6 o'clock exactly, okay, at 6 p.m. on special classes, in my special classes, you people are supposed to join me, because I'll be showing you the previous year questions and some of the killer questions on this relative motion, like Rain Man problem, river boat problem, river swimmer problem, in that one. Okay, let's get started. With the speed of light, we have to move. Okay, let's talk about every damn thing that we need to basically focus on. Now, first of all, what is this relative motion? Let me just explain you in a very beautiful manner so that you'd be able to understand every damn thing. So before this, I'll make you understand what is this frame of reference exactly. What this frame of reference exactly is. Now see, I'll make you understand what is this frame of reference. For example, this is a truck, this is a bus, this is moving in the forward direction. There are two people inside this bus. This is A and this is B. Understand? So this is the person C who is exactly at the ground. Okay. Now I asked this person C that you tell me is this A exactly in motion or is this A exactly at rest? The person C is telling me this truck is moving in the forward direction. Clearly, understand, this truck is in the motion. So clearly this A is also in the motion because he is inside the bus. So C is saying basically A is in motion. Understand? According to this C, A is in motion clearly. Understand? Now I ask this person B. Now I ask this person B, that is this A exactly in motion or is it at rest? The person B is telling me that the person A is exactly on my side. Okay, he is sitting on my side, so we can interact with each other, we can share everything we want with each other. So definitely he is at rest because they are sitting inside the bus only. So B is basically saying that A is at rest. A is at rest. Understand? Now you tell me one thing, who is basically lying and who is telling the truth over here? Understand? Who is exactly correct, C person or B person? Understand? C person or B person. So C person or B person. Now in this case both are correct. When we take this as a frame of reference, then this A is in motion. When we take this B as a frame of reference, then this A is at rest. Understand? So previously the question was incomplete. I would have asked you that according to what frame, understand, in what frame, according to what person this A is in motion, according to B or according to C, understand, then it is the complete question. So over here we can say when we take this as a frame of reference, then this person A is in motion. When we take this B as a frame of reference, this A is in motion. Frame of reference, it completely depends upon us. You can take anything. If for example there is some other person or there is some tree over here, you can take that also the frame of reference. Understand? So in what frame you are talking about? So this is called the frame of reference. Understand? With respect to what you are talking about, you are saying this car is having 50 meter per second velocity. With respect to what I am talking about? Understand? So that is frame of reference. So over here we took previously C as a frame of reference. Now we took B as a frame of reference. Even we can take A as a frame of reference, and we'll talk about the motion of a B as well. Understand? So this is the concept of frame of reference. Okay. Chill scenes, everything, I'll complete everything, projectile motion, everything. It's not a problem. You will get no problem when you go through this one. It will not bother you at any point. So definitely, so you don't have to read, you don't have to basically learn the projectile motion before relative motion, not at all. Okay, I'll make you understand everything without the projectile motion itself, don't worry. Okay, so this is what we call the frame of a reference. Now let's move on to basically this one. Same concept we're going to be using in this one. So first of all, in order to understand, now what is this relative motion? Relative motion is what? Means if we are talking about this person A, this person A is in motion or rest according to what? Relative to what? Is this, when we talk about relative to this person C, this is exactly in motion. Relative to this person A, this is exactly at rest. That is what we call the relative motion. You'll get to understand everything. With respect to what we are talking about, that is relative motion. Understand, that person is moving. Relative to me, is that in motion or is that at rest? That is what we call the relative motion with respect to what we are talking about. You'll get to understand. Just give me few more seconds. I'll make you understand this very clearly. Listen to me very clearly. Okay. I am saying that, for example, this is a car A over here, this is a car B over here, this is a car C over here. Okay, so this car C has traveled 40 kilometers of displacement. Understand, this is at 40 kilometers. For example, if we take this as a reference frame, means if we, for example, not reference frame, if we, for example, say we are measuring the displacement from this point where exactly A is right now. So this is at 40 meters, 30 plus 10, it has covered the 40 meters. Okay, fine. Now, this B car has covered how much of distance? A displacement 30 meters clearly. Now I am asking this person B who is sitting inside this person, this car B. I'm asking this person B, tell me what is the displacement of C? Understand? So this B is saying that displacement of, I'm asking this person B, displacement of C with respect to this B. Understand? With respect to this B. Understand? In relative to this one. Clear? Is there any confusion till here what I am talking about? Okay, so I'm asking this person B, what is the displacement of C? So person B is saying that, how can I find the displacement of this car C? So he's saying that how much I have calculated, that is how much? 30, and how much C has calculated. So it is basically comparing the displacement of C with himself. Understand? So it is comparing the displacement of the other car, this C, with himself only. That is the displacement of this car with this. Subtracting. What is, if I ask you how much money does that person have? This is a person A. Okay, this is a person A. This is me. If somebody asks me how much money does this person have, I'll basically see how much money does I have, how much money this person have. So I'll subtract that money with my money and there will be some difference. Understand? So that is money of this person in respect to me, with respect to me, according to me. Understand? So that is basically the concept over here. Now, same is the case of relative displacement. Understand? I'm asking this person B how much a displacement it has covered. It is saying it is clearly that this has covered 40 kilometers from here to here and I have covered 30 kilometers. So according to me, it has covered only 10 kilometers. Why? Because it is only 10 kilometers far from me. So I can say according to me, not according to any other person who is at A or who is at some other point. So that is the main concept. So can I say in that case, the displacement of C according to this B is nothing but only 10 meters, 100%. How did I calculate this? Displacement of C according to B is nothing but displacement of C minus displacement of B. How much is the displacement of C from that point if we are measuring from that point? So that is clearly 40. This has covered displacement of B is clearly 30 and it is nothing but 10 meters. Understand? So displacement of the other car, subtract the displacement of yours, whatever the displacement you have covered, you will get the displacement of the other car with respect to you. Fine. Same. Now, if I ask this person A, how much is the displacement of this one? It is clearly saying that it is 40 kilometers away from me, 30 plus 10, 40 kilometers. So displacement of this C with respect to A, or according to this A, we can say it like that. According to this A, it is nothing but displacement of C minus displacement of A. So how much that is? That is clearly 40 minus 0, that is 40 meters. So this is what we call the relative displacement. Relative displacement of what? Relative displacement of C with respect to this one. Understand? So relative displacement means what is the displacement of that car in respect to me. Understand? With respect to another car. So everything is relative over here. Like we say, for example, you are measuring the displacement of this car from ground itself. From ground you are saying 40 kilometers. So what is that exactly? So that is also the relative displacement, but over there you are taking the reference frame as a ground. Understand? So over there you are taking the reference frame as ground. So in that case, that is also the relative displacement. Displacement of this car with respect to ground. Displacement of this car with respect to ground. So this we take basically from the ground frame. From ground. You'll get to understand everything. Now if we talk about the relative acceleration, what is that? If I ask you what is the acceleration of B with respect to this A, you'll clearly say, sir, it is very easy now. How much is the acceleration of B and how much is the acceleration of A? Subtract them. So that is acceleration of B minus acceleration of A. So can I say that is 4 minus 1, it is 3 meter per second square. So this is a relative acceleration of B. Understand? Now you got the feel of relative acceleration, relative displacement. Come on in the live chat. I just need to know. So this is basically the concept of relative acceleration, okay? Relative displacement. What is the displacement of this car with respect to some other car? What is the displacement of this with respect to ground, okay? Yeah, got the feel. That's great. Now the point comes relative velocity. What is relative velocity now? Nothing. What is the velocity of other car with respect to this car? What is the relative velocity of that car with respect to this car? Relative. In relative to me, in relative to some other car, in relative to this tree. That is what we call the relative velocity and nothing else, okay? Now over here, if I ask you what is the relative velocity of a B with respect to this A, you can clearly tell me. What is the relative velocity of A with respect to this B? You can clearly tell me now. Okay? Hi, sir. What's up? Okay. Now, sir is in the chat. You can say hi to him. Too much energy. Yeah, not that much. Thank you. Thank you. Thank you, sir. So you basically have to tell me over here what is the relative velocity of this A in comparison to this one, understand? Or relative velocity of B in comparison to this one. That's very easy, okay? So you will simply say that is velocity of B with respect to A is nothing but, I'm asking you what is the velocity of B with respect to this A. If the person is over here inside this car, if I ask him how much is the velocity of this car, he'll say, sir, the velocity of that car is basically how much velocity I have and how much velocity that car B has. So subtract that one with my velocity, I'll get the velocity which is basically the difference velocity. Understand? What is the difference between two cars? That will be the relative velocity over here. That is velocity of B minus velocity of A. So keep this thing in your mind. This is nothing but from ground frame. This is from ground frame. Means, for example, if the person is over here, if I ask him, what is the velocity of this car B? He'll say, I have velocity 0 because he's at C. This has velocity. Velocity of C is basically 0. He's exactly at rest. He's at ground. Okay. Thank you, sir. Thank you so much. Okay. So he'll say basically according to this person will have the velocity 0. So this car will be having the velocity of how much? 5 meter per second, because 5 minus 0. According to ground, if we say velocity of B with respect to ground, that is velocity of B minus velocity of ground. So this is having 0. So velocity of B is how much? That is 5 minus 0. That's 5. That's why I'm saying according to this person who is exactly at ground. So it will be 5 meters only. So he is basically saying this is going with a 5 meter per second. So this is observing this velocity also. He is going, this car also, he is going with 1 meter per second also. So clearly velocity of B with respect to A, that is velocity of this car with respect to this car, that will be velocity of B with respect to ground, how much? That is 5 meter per second. So velocity of A with respect to ground, according to this is moving with 1 meter per second. So that is 4 meter per second, positive 4 meter per second in the forward direction. Understand? Yeah. Okay. Now the point over here is, that is, now if I ask you what is the velocity of A with respect to this B, that is velocity of A with respect to B. Understand? This is what we call the velocity. Understand? Finding the velocity of some other car with respect to you. Finding the velocity of that car with respect to some other car. That is only the relative velocity. Okay. Now, can I say velocity of this A? He will basically velocity of this A with respect to B. Now, this car is observing how much velocity does that car have in respect to me, with respect to me. Understand? When this car is basically observing. So it will clearly say that is velocity of A minus velocity of B. So how much is velocity of A over here? Velocity of A is clearly this, that is 1, minus velocity of B is how much? That is 5. So can I say how much? This is minus 4 over here. Why the minus 4 is basically coming in that case? Because see, now I'll give you the real feel of this one. Okay. I'll give you the real feel of this one. If, for example, you are sitting inside this car, okay, you are moving with 5 meter per second in the forward direction, and the other car who is exactly at your back, that car is moving with 1 meter per second. So you will feel, you will observe, like you will get the feel like this car is moving in a backward direction. Understand? You imagine this. Understand? You do this experiment that you are sitting in some car that is moving with very high speed, and the other car which is moving with a normal speed. You will feel like when you are going in the forward direction, you will feel like the other car will exactly go back. That's moving in the backward direction. That's why we are getting negative 4 meter per second. So according to this car, the person who are over here, if he is observing that car, it will, for this car, see, if the person is exactly at ground, for that person, it will move in the forward direction clearly. But according to this person who is exactly in this car, moving with 5 meter per second, he'll feel that this car is moving in the backward direction with 4 meter per second. You observe this, understand? You do the stuff. Okay, you do the experiment, you will get the feel exactly. Now, find the velocity of B, find VAB and VBA, means velocity of B with respect to A and velocity of A with respect to B. So it's very easy now. Velocity of B with respect to A, we can clearly say velocity of B minus velocity of, this is from ground. So how much this is, if we observe this car from the ground frame, how much does it have? It will have, that is 30, understand, 30 meter per second, and minus what is velocity of A, you will clearly say that is nothing but 20, sir. So how much this will be? This will be 10 meter per second. So if this car is moving in a forward direction, Basically, according to this car, this is moving in with 10 meter per second only. This is moving with 10 meter per second only. Okay, fine. Yeah, velocity of AB. Now, if we find velocity of AB, that is nothing but velocity of A minus velocity of B. So how much is velocity of A from the ground? You can clearly say that that is 20 minus how much velocity of B? You can clearly say that is 30. So this will be minus 10 meter per second. Means if you are basically sitting inside this car and if you observe this car is moving from your back, so for you it will appear like it's moving in the backward direction with a 10 meter per second, 10 meter per second. So everybody is understanding this one. Come on. These are the basic cases. Okay, I'll be showing you previous year questions on this relative velocity tomorrow in the special class at 6 o'clock. So don't forget to join that. Okay. Yeah. Can you tell me VAB and VBA, velocity of this car B, it is moving in the backward direction, this is moving in the forward direction. Okay, this is car A, this is car B, this is B and this is A. Can you tell me velocity of A with respect to B and velocity of B with respect to A? Yeah, tomorrow will be no class for 12th class. Okay, no class for 12th and we'll have to basically go in the special classes today, tomorrow. Come on, can you tell me velocity of A with respect to B and velocity of B with respect to A? Clearly, I can see velocity of B with respect to A is nothing but velocity of B minus velocity of A from ground frame, Velocity of B, how much? Velocity of B is basically how much? 30 or minus 30? It is clearly minus 30 because it is moving in the backward direction. Understand? So velocity of this B with respect to this minus. Velocity of A is how much? 20. Understand? 20 in forward direction. So we take basically velocity as positive. If the body is moving in the right direction, we take velocity as positive. If the body is moving in left direction, we take velocity as negative. So it will be nothing but 20. So velocity of B with respect to A means velocity of this car according to this car. So that is nothing but minus 50 meter per second. What is that? What is that? What is that? Not 50, it is minus 50. Why is it minus 50? See. Why is it minus 50? If you are, for example, traveling through any car, you are inside this car, okay? You are inside this car, car A. You are moving with 20 meter per second like this. The another car is traveling in backward direction. You are moving in forward direction, that's moving in backward direction. So when you cross each other, it feels like that car is moving with hell lot of speed. Why is it like that? It is because of relative motion seen. Physics works. According to the person who is at ground, according to him, this is having 30 meter per second only in the left direction. According to this person, this is having 20 meter per second only in the right direction. But if you sit inside this car, the velocity will double. Understand? It will increase because this is the scene. This physics is everywhere. Yeah, physics is everywhere. Understand? See. Why will it basically happen? So if it is saying that 50 meter per second, okay? So when it is basically, when you cross that car, so you'll feel like the other car is having hell lot of velocity. But in what direction? That's moving in backward direction, nah? According to you. So if that is moving in backward direction, that's why negative sign. And velocity is too much, that's why 50 meter per second. Now you got the feel of this one. Why minus 50, not plus 50? Now if I ask you, how much is velocity of A with respect to B? Means now if you are sitting inside this car, how much is the velocity of this A according to you? You'll say, sir, velocity of A minus velocity of B clearly. So how much is velocity of A? You'll say, sir, that is 20. Understand why 20? Only 20 plus 20 in the forward direction. And how much is the velocity of this one? You will say, sir, that is minus. And this is also having my negative velocity because I'm moving in towards the left. So this is minus how much? 30. So this will be nothing but plus 50. This will be plus 50. What is this? This is velocity of A with respect to B. Means if you are sitting inside this car, observing the car, when that car crosses you, so that is having the hell lot of speed. But what? Towards the right. That's why it is coming out to be plus 50 meter per second. Come on, you understood this? Yeah. Thank you. Love you too, bro. Yeah, it will be plus 50 now. Come on. Let's move on to the next one. If we have this question, find in this case, find a velocity of AB velocity of this car, this is A, this is B. Velocity of A with respect to B and velocity of B with respect to A. Come on, tell me how much will be the velocity exactly over here. You will say, sir, it is very easy now, okay? Velocity of A with respect to B will be 40. Huh? Velocity of A with respect to B is how much? Come on, I need to know in the live chat. Come on, all of you. Yes, it will be 0 exactly. So this is velocity of A minus velocity of B. So velocity of A is how much? That is 20 in the forward direction. That is 20 minus velocity of B with respect to ground. It is also 20. Both are moving parallelly. So this is 20. It will be 0. So if the person is exactly at the ground, he can see both the cars. This person can analyze both the cars. They are moving with 20 meters per second. That's okay. But if you are sitting inside this car, your friend is sitting inside the another car, you're moving parallelly, same velocity. So for you, it will appear like the other car is at rest. That is moving with 0 velocity because you can talk to each other. Hey, what's up? What's going on? Huh? You were on a date yesterday. So you can basically talk to each other. You can have chat with each other. You can even give something to each other. So it feels like for you two, you are at rest. But some other person who is exactly at ground having 0 velocity, for that person, you'll be having some velocity. But you two, with respect to each other, will be having 0 velocity. Same goes for VBA. That will be also 0. Understand? Yeah. This is the basically clear feel. You have to compare these examples, these concepts with the real life situations. Then only you'll get to understand the real physics. Understand? Okay. Now, this is the another question. Over here, I'm asking you, what is the velocity of this car C? Velocity of car C. Velocity of this car C with respect to ground. Velocity of this car C with respect to this truck. Come on. Inertial frame, non-inertial frame, we'll talk about that later, okay? Chill scenes. There has to be a proper sequence, understand? There has to be a proper sequence. Like when we come on to that topic, we'll accordingly talk about that as well. But this is related to that definitely. Okay. Then we'll apply the pseudo force also. Yeah. So first of all, we need to basically find a velocity of this car. First with the normal observation. See, if for example, there is a person over here who is exactly at ground, understand? So this person is observing this car. So this truck is moving with a velocity of 20 meters per second. So he is observing this car. If this is moving with a 20 meters per second and this car is having his own velocity of 5 meters per second as well. So according to me, this car is having 20 plus that 5 means 20. 25 exactly according to this person. So can I say velocity of this car with respect to ground will be nothing but 20 plus 5, that is 25. We'll prove with the relative velocity method also, okay? So for now, a 0, how 0 bro? Come on. I'm saying you velocity of this car with respect to ground, understand? This is having 20 meters per second. This is having its own 5 meters per second, understand? So 20 plus 5. So this person will basically observe that this is having 25 meters per second. Now, velocity of this car with respect to truck means if there is a person over here, okay, there is a person, he is exactly on the truck. So this person is also having how much of velocity? The truck's velocity, that's 20 meters per second. If this is observing this person, so according to this person, this guy who is on the truck will have only 20 meters per second. That is the velocity of truck, understand? So according to this person, this car will have the velocity of truck and velocity, its own velocity 5 meters per second. But this person is also having his, that is the 20 meters per second. So according to this person, he will basically find that this car is having only 5 meters per second coming towards this person. So that will be nothing but 5 meters per second. How many of you people understood this? Come on, in the live chat. Come on. I just need to know in the live chat. Minus 15, how? How will it be minus 15? Now see, if we prove this from the relative velocity method also, so how much is that? Velocity of this car with respect to truck, how much that will be? You will say velocity of this car minus minus velocity of truck minus velocity of truck. You will say velocity of car is how much from the ground? You will say, sir, from this ground frame, this car is having 20 plus 5, that is 25 meter per second, minus negative. Velocity of truck, how much? This person is observing this truck is having only 20 meter per second, so it will be 20. So that is nothing but 5 meter per second that we exactly got over here. Now you can find this velocity of car with respect to ground as well. So how much that will be? This is the ground with respect to ground frame, with respect to ground frame exactly. 1 second, guys. Hello? Assalamualaikum. Walaikum salam. Busy. Wala bakra your phone. Okay. So now if you basically find this velocity of this car with respect to ground, understand? Velocity of this car with respect to ground. So you take this over there. So can I say velocity of this car with respect to truck plus this velocity of truck with respect to ground? So how much that will be? How much we got this velocity of truck with respect to car? That is 5 plus velocity of truck with respect to ground, that is 20. How much that is? 25. Why are you saying minus 15? That yes, I do know. Okay, now you tell me in this case, now here you will find something very new, very interesting. What is that? If I ask you to tell me the velocity of this car with respect to ground and velocity of this car with respect to this truck, okay, tell me how much it will be exactly. Come on, I'm waiting for your answers. Can you tell me in the live chat? Now see, this car is having 5 meter per second in the backward direction. This truck is having 20 meter per second in the forward direction. If, for example, there is a person who is analyzing the situation over here, he can clearly say this car is having two velocities. One of its own velocity, that is 5 meter per second. Another velocity is because of this one, that is 20 meter per second. Understand? So 20 in the forward direction, minus in the backward direction. So 20 plus 20 minus 5. So plus 20 minus 5, that is plus 15. So this velocity of this car with respect to ground will be nothing but plus 15 meter per second clearly. And if we talk about this car from the ground frame, this was from the ground frame itself. And if we talk about this car from this frame, who is exactly over here, exactly from this truck frame, the person who is exactly on the truck. So according to this person, this car is only moving in the negative direction. Understand? It will be having minus 5 only. So can I say V of C with respect to truck, it is nothing but minus 5 meter per second, because this truck is itself, this person is itself moving with a velocity of truck, that is 20. Yeah, exactly. That's great. Now, see, there are so many questions that we need to solve on this relative velocity method, as I have to complete the 3 or 4 topics in this session. That's why I didn't take that much of questions in this session. So I suggest you people to join me in my special class tomorrow at 6 o'clock. I'll be showing you the next level questions. Okay, next level questions for sure. You will love those killer questions on this one, because this is highly important topic. So special classes tomorrow. And one question I'll be I'll try to show you over here. 1 second, I'll just add. This was asked in JEE. 1 second. This was asked in JEE 2000 mains 2020. Okay. Yeah. Why is this lagging, man? Let me just show you what is this question exactly is. I want all of you to basically answer me this question. So this was the question asked in JEE 2020 mains. Okay, mains. Okay, what was this question exactly? Listen to me very carefully. Okay, so there was basically, this is a car, this is moving in the forward direction with 2 meter per second square acceleration. Okay, it started from 0, understand, from rest, and this is the bus. Okay, this is the bus. This is moving in the forward direction. This is moving with 4 meter per second. Okay, 4 meter per second square, 4 meter per second. So 4 meter per second square, this is 2 meter per second square, exactly. Distance between these two is basically 200 meters. And you are supposed to tell me, when will this car catch this bus exactly? At what time this will catch this car, this bus exactly? Come on, can you solve this? I just need to know in the live chat, can you solve this question? See, simply, both started from rest. You can use S is equal to ut plus half of at square. Now see, what is the acceleration that you're going to be finding over here? See, you need to find relative acceleration over here. See, this is moving with 2 meter per second square. This is having 4 meter per second square. What is the relative acceleration? What is the acceleration of this B in comparison to this C? It will clearly say acceleration of this C in comparison to this one. It will clearly say acceleration of C minus acceleration of B. Clearly, how much that will be? Acceleration of this C with respect to B, that is 4 minus 2, that is 2 meter per second square. So we got the relative acceleration. Now you need to use the formula in order to basically calculate in how much time it will basically catch this bus. It will catch this bus. So use in this one only. So this is the case of relative motion. So instead of acceleration, if you say, for example, S is equal to ut plus half of, that is at square. Over here, acceleration you put as a 2 meter per second square, because the difference acceleration, relative acceleration is 2 meter per second square only, because this acceleration will exactly give you the information in how much amount of time it will catch this bus exactly. So can I say this is nothing but how much is the difference? That is 200 is equal to, initially started from 0, so this will cancel. So 1 by 2. So how much that is? This is 2. This will be t square. This will cancel. T square is equal to root of 200, that is 10 root 2 seconds exactly. Okay, so this was the question in JEE Means 2020. Yeah, okay, now we need to basically go for this Rain Man problems. What is this Rain Man problems? This is not the Rain Man problem, it is actually the Rain Man problems. Okay, constant acceleration case. Okay, this is a case of constant acceleration exactly. So but we need to exactly find the relative acceleration in that case. Okay, fine. Now you tell me one thing, what we are supposed to find in this case is Rain Man problems. Listen to me very carefully. If I ask you, for example, the rain is falling over here, it is basically save yourself from rain. Okay, if I ask you, for example, the rain is falling in this case, now you are supposed to save yourself from rain. You need to save yourself from rain. What will you say? If this is falling in the vertical direction, will you open the umbrella like this? Definitely not. Will you open the umbrella like this? Definitely not. So you will open the umbrella exactly opposite to the rain. If rain is falling vertically downwards, you will open the umbrella so that you save yourself from rain. So this is the first case. Okay, now if I say the question can be like this, that's why I told you this is the Rain Man problems. You need to save yourself from rain. So what can be the questions asked in this concept, that I'll tell you. Now see, if for example this is a rain falling over here and this is the wind. Okay, this is the wind, rain is falling vertically and this is the wind that is hitting this rain. So afterwards, how will the rain fall? You are sitting on the ground exactly over there. So how will the rain fall? Rain will exactly fall like this, at some angle with the vertical. Fine, clear. Now the point over here is, if I ask you, you need to save yourself from rain, how will you open the umbrella? Will you open the umbrella in this direction, exactly in this direction? No, because the rain is hitting your face, it is hitting your face. So definitely you are not supposed to open the umbrella in the opposite direction to the vertical. Definitely not. So how you are supposed to open the umbrella? Something like this, so that you save yourself from rain. Now the question can be asked over here is like that. So at what angle this theta with the vertical, you need to basically keep the umbrella, you need to place the umbrella, set the umbrella in order to save yourself from rain. Find this theta. So this can be the question asked, this one. Or they can ask the question, what is the velocity of this rain with respect to this man? According to you, what is the velocity of this rain? Now, another question can be something like this. If I ask you to move in the forward direction and this rain will basically appear to fall in vertically downward direction. In that case, how much is the velocity of rain? How much is your velocity with which you are moving? So these can be the questions asked in this one. So that's why I'm saying this is not the rain man problem. This is the rain man problems. Understand? Everybody understood till here? Give me the signal in the live chat. Drop a thumbs up. Come on, all of you. Okay. Yeah. We'll start the course on Plus as well. Okay, that's great. Now see, listen. This is one of the common questions that might have basically come in your mind, that might be messing with your mind. Why do we feel rain is hitting our face? For example, you are sitting at the ground, exactly, fine, mast okay, chill, and rain is falling vertically downwards, hitting your head. You're opening an umbrella and you're saving yourself from the rain. Fine, that's clear. Now, when you started moving on the bicycle or when you started running, in that case, it appears like if you started moving on the bicycle, it appears like rain is hitting our face. Why is it like that? Oh, what is the logic behind this? What is the real feel behind this? Okay, do you want the real feel? Do you want me to give you the real feel of this concept? So in that case, you need to basically place the umbrella in such a way like this, at some angle with the vertical. Okay, so you will save yourself from this rain. You'll save yourself from this rain. Why does it exactly happen? When you basically come to rest, once again, in that case, it will appear once again the rain is falling vertically downwards. But when you start moving in the forward direction, over there, you'll basically feel like the rain is coming and it's falling on your face. It's hitting your face. Why is it like that? Let me just give you the feel. So before that, I'll have to basically make you understand this example. This is a very beautiful example. Okay, you'll definitely like it. You'll definitely love it. Now listen to me very carefully. Listen to me very carefully. I'm saying that this is a plane, okay? This plane is moving in the forward direction. This plane is moving in the forward direction, okay? This is in the air moving with, for example, I would say 10 meters per second exactly. Fine. And this plane exactly released the package, okay? This package, imagine there is no air friction, no fluidic friction, air resistance, whatever you say. There is nothing like that, okay? We're neglecting that because that will reduce the velocity of this one. That's why. So basically, it is releasing this package. Now, if I ask you what can be the velocity of this package, if I say, for example, the downward velocity of this package with which it is falling, that is 5 meters per second. Okay, chill, no confusion still here. And it will have the horizontal velocity also. Why? Because the plane is having horizontal velocity. It is releasing the package, so it will have horizontal velocity. It will go down. Gravity will basically attract this, so it will have vertical velocity, it will have horizontal velocity clearly. So I am saying that horizontal velocity will be exactly the velocity of plane. So that is nothing but 10 meters per second. Okay, there is this another car which is moving on the road. This is exactly, the plane is over here, the car is exactly over here. Understand? They are moving parallelly. So this car is moving in the forward direction with same 10 meters per second. Understand? This is the case over here. Now, if I ask you the question, very simple question, very common question, tell me this person, according to this person who is exactly at ground, this person is at ground. According to this person, if I ask this person, bro, you tell me one thing, what is the path of this package? What is the velocity of this package? This person is clearly telling me the plane is releasing the package. So according to me, if I'm exactly at ground, at rest, so this package will basically fall something like this. This package will fall something like this. This package, is everybody agreed with this one? Is everybody agreed with this one? Fine. So according to this person, this will fall like this. But if I ask this person who is exactly inside this car, if I ask this person, bro, you tell me one thing, what about this package? Is this package moving like this? Is this package falling like this? Falling like this, something like projectile path or something like that? This person is telling me, no, exactly not. It feels that for this person, this package is falling vertically downwards. So when the car is exactly at here, this is exactly on its head. So if I ask this plane person also, where is this package? The plane will say, the plane person, the pilot will basically say, the package is exactly on this line, on this vertical line, near me, under me, clearly. So, but this person is saying this is falling like this. This is saying it is going vertically downwards. This car person is saying it is going vertically downwards. Who is exactly telling the truth over here? Yeah. So this is the scene. Understand? I'll tell you what is basically happening. Now, this is the case of relative velocity. This is the case of relative velocity. Let me just make you understand why does this exactly happen. Okay. Now see, according to this person, this is a car. Understand, this is a car. This is a car person. So I'll ask you to tell me velocity of this package with respect to this car, according to this person. You'll say that is, sir, velocity of this package, if I call this as package, according to this car, this will be something like this. Means we're finding the velocity of this package according to this person. Let's see what will that come. What will that be exactly? So can I say that is velocity of this package with respect to ground, velocity of P minus velocity of C with respect to ground 100%. So can I just say velocity of package with respect to this car is nothing but, yeah, velocity of package. Velocity of package with respect to ground is what? This person who is exactly at ground, he is clearly saying that, sir, it is having vertical velocity as well as horizontal velocity. That is why it's moving in this path exactly. So according to this one, which velocity it's having? Vertically downwards, horizontally downwards. If, for example, there is a vector in this positive x-axis, we say we represent that with I. Unit vector gives us the direction of along any vector. You might have studied this one. Understand? So we say if this is moving in the negative direction, we take that minus I. You might have studied this. Okay. So we take this as plus j, we take this as minus j, and we take this as plus k, we take this as minus k. Might have studied this one. So same as this is basically used for direction purposes. In which direction the vector is exactly. Okay. Now you tell me one thing. So you tell me one thing. According to this person, this will have two velocities. One in the plus I cap, another in the negative j cap, because this is in the downward direction as well, horizontal velocity as well as vertical velocity. Can I say over here that is horizontal velocity is how much? Can I just say according to this one that is plus 10 I cap clearly, or 10 I cap directly, and this is how much? This will be nothing but minus 5 j cap exactly. Fine. So just write it over here. Velocity of package with respect to ground, velocity of this package with respect to this ground will be nothing but that is plus 10 I cap, and then this negative 5 j cap exactly. Now, and then it will be this minus as it is. So velocity of this car with respect to ground. So this person is observing the velocity, this person is observing this car, it is completely moving in the horizontal direction, moving towards right. So this is having plus 10 I cap. So this is having plus 10, this minus is as it is, so plus 10 I cap. Don't say this is minus for that, this minus is as it is, minus of the formula. Okay, so can I say this will cancel? So velocity of package with respect to car is nothing but only minus 5 j cap. Means minus 5 j cap. Can you draw it? So minus 5 j cap, this is 5 j cap in downward direction, means this is velocity of car, velocity of package with respect to car. Means according to this car, this package will have only 5 meters per second, that too in negative direction, minus j cap, that is 5, minus 5 in the negative direction. That's why this is basically the scene of relative velocity. Physics works everywhere. So for this person, it will appear like it is falling in the downward direction only. It's falling vertically. This person will feel like it will fall on me only. But according to this person, it will have two velocities. So basically, this velocity, he is himself moving with a 10 meters per second. This 10 will cancel with this 10. And this will basically appear in downward direction. Okay? Come on. You understood this one. You got the feel of this one. Huh? Same logic we need to use in the previous case. Now, same logic we need to use in this case. So basically, when this bicycle moves in the forward direction, so for him, it will appear like the rain is falling like this. Why? Because this is the scene of relative velocity. Understand? This is the scene of relative velocity. But for this person who is exactly at ground, or if this stops, so it will appear like rain is falling vertically downwards. Why? Let's find the proof. So we need to basically find in this one velocity of this rain, velocity of this rain with respect to this man. Understand? Velocity of this rain with respect to man. Now, can you tell me how much it will be exactly in this case? He'll clearly say, sir, it is nothing but velocity of this rain with respect to ground minus velocity of this man with respect to ground clearly. Can you tell me? So velocity of this rain with respect to ground is how much? He'll say, sir, it is nothing but 10 minus 10 j cap in the downward direction, velocity of this rain. Because if, for example, this person is exactly at ground, okay? So according to this person, this is falling vertically downwards. So it is nothing but minus 10 j cap directly, because in the downward direction, and this negative as it is, and velocity of this man with respect to ground. So this person is observing this car, this bicycle person, it is moving in the forward direction with how much velocity? 5 meter per second velocity. So it will be 5 I cap only. Understand? Now this is the velocity of this rain with respect to man. So can you draw this? Can you draw this vector velocity of rain with respect to man? It is very easy. 10 j cap. So it will be something like this. 10 j cap, okay, in the downward direction. 5 minus 5 I cap. So it will be something like this in this minus 5 I cap. Now, if this is in the backward direction, okay? If this is in the backward direction, this is in the backward direction, this is in the downward direction. So can you tell me the resultant? So resultant will be something like this. So resultant will be something like this. Resultant will be something like this. So what is this result? This is basic. We are drawing this vector over here and we got the resultant of this vector only. So what will be this? The resultant of this. So can I say this is velocity of rain with respect to man? Velocity of rain with respect to man. Understand? So this will be nothing but, that's why it feels like for this person it is falling on my face. So physics works. Physics works. Okay? Come on, understood? Everybody, I just need to know in the live chat if you understood this concept. Now we need to move on some problems, okay? The concept was still here only. I'll tell you how to find the resultant, chill scenes. Root of this square plus root of this square, understand? Resultant VRM is nothing but root of this square plus this square. Yeah. Okay. And you can find the theta also. If I ask you the question, at what angle you need to find the theta? Okay, let me show you the question. So this is the question. Tell me, find the angle at which you need to place the umbrella to save yourself from rain, and also find velocity of rain with respect to man. Tell me, come on, in this live chat. In the live chat, come on. I need to basically know the answer of this question. Find theta and find this. Come on. Now, so basically, velocity of rain with respect to man, that we need to basically find out in this one. Velocity of this rain with respect to man. Can I say velocity of rain with respect to ground minus velocity of man with respect to ground? 100%. So how much that is? Velocity of rain with respect to ground. There is a person over here. According to that person, this rain is falling vertically downwards. But this person is moving in the forward direction. So for him, it will appear like the rain will fall vertically on me, on my face, exactly. So if this rain is falling vertically on his face, so he has to basically open the umbrella in such a way at some angle to save himself from rain, exactly. So he need to basically open the umbrella in such a way at what angle, this angle we need to find out exactly. Because rain is falling vertically on his face, so he needs to place the umbrella at some angle. So we need to find this angle only. And velocity of rain with respect to man. According to this person, how much will be the velocity of rain? Come on. So can I say velocity of rain with respect to ground is how much? That is minus 12 j cap in the downward direction. This is falling in the downward direction, minus 12 j cap over here. And this negative as it is. And velocity of man with respect to ground. According to this person, how much is the velocity of man? That is 12 root 3 only in the forward direction. That is I cap. Okay. So this is VRM exactly. Now can you draw it over here? So can you draw it over here? So it will be 12 j cap. So it will be 12 j cap exactly. And this will be nothing but 12 root 3 I cap in the backward direction, minus 12 root 3. That's why I cap. So this will be having the resultant, this one, understand? So can I say this is nothing but how much will be this resultant? How much will be this VRM? Can you tell me this VRM will be nothing but that is root of this 12 root 3 its square plus this 12 square exactly. So find this one and tell me how much will be the angle at which you need to basically my blessings are with you. Okay, go kill it, get 100 percentile. Okay, now you need to basically place the umbrella in such a way so that you save yourself from rain. If rain is falling in this direction like this, so you need to place the umbrella exactly opposite to this rain. So at what angle you need to find this angle theta. So if you get this theta, you'll get this theta exactly, opposite angles. Okay, now you tell me one thing, how can we exactly find this one? It is very easy. Parallel shift of vectors. Can you parallel shift that vector over here? Okay, that vector. So this is 12 root 3 exactly. Now tell me in this case, how much, what will be the value of tan of theta in this case? Come on, in the live chat, I need to know. 45 degree or 60 degree? Come on. So can I just say over here, that will be tan of theta in this case will be nothing but, that is this 12 root 3 perpendicular upon this base, tan theta perpendicular upon this base, that is 12. This will cancel root 3. When is the value of tan theta is equal to root 3? When theta is equal to 60 degrees, I guess. Okay, 60 degrees. Okay, so this is how you are supposed to exactly find out. So this is the very important question, very good question. If you can solve this one, I'll send you the 500 rupees right now, right here in the Paytm. Send me your number. Okay, but before that you need to answer this. Come on. Yeah, I'll give you time. I'll give you time. Solve this, okay? Even I can explain. I'll explain you the question as well. A person is observing rain at 20 meters per second at 30 degrees at rest. Okay. When he starts moving and observes rain falling vertically downwards, find the velocity of man due to which he observes rain falling vertically. See, what is the question? I'll make you understand. A person is basically exactly at rest. Understand? He observes that rain is falling at him at 30 degrees Celsius with 20 meters per second. He's at rest. So rain is falling at 30 degrees Celsius, 30 something like this. Okay, 30 degrees Celsius. No, not 30 degree, not Celsius. Arre yaar. 30 degree at 30 degree angle. Okay, with velocity 20 meters per second. Understand? It's falling at him. So when he throws his umbrella, he starts running. When he starts running with some velocity, he observes that now rain is falling vertically downwards. It happens because this is the case of relative motion, relative velocity. So now he observes that rain is falling vertically downwards on him, hitting his head. What is his velocity? Velocity of man. What is his velocity with which he is observing rain is falling vertically downwards? That you need to basically solve. There are two methods solving this. I suggest you to not solve with the relative velocity method. Use the vector method. Okay? Come on. See, I'll solve it. No expectations from you people. Okay. A person is observing rain at 20 meters per second at 30 degrees Celsius, at 30 degrees at rest. Means when the person is exactly at rest, okay, he is observing the rain at, I would say 30 degrees, okay, 30 degrees. For example, the person is over here, the rain is falling at 30 degrees at him. Understand? With what velocity? That is 20 meters per second. So can I call this as velocity of rain? 100%. Why velocity of rain from the ground perspective? Because you are at rest. If there is another person over here who is at rest, so according to him only it will fall at 20 meters per second at 30 degrees angle. Now you will have questions, sir, how is it possible that rain can fall at 30 degrees Celsius at an angle when even you are at rest? Maybe because of some wind. I told you in the beginning itself. So wind is basically hitting the rain. That's why rain is falling at 30 degrees itself. Understand? Even if you are at rest. Fine. So now question is, when rain starts moving, when this man starts moving in the forward direction with some velocity. So when this man starts moving, this velocity of man in the forward direction, when this man starts moving in the forward direction with a velocity, I would say that we need to basically find out. So in that case, how much will be, if this man is observing rain is falling vertically downwards on him. So in that case, see, when this person starts moving in the forward direction with some velocity Vm, in that case, it observes that the rain is falling vertically downwards. That is velocity of rain with respect to man. Understand? So this is the relative velocity of rain with respect to man. Now, when is the person observing this? When he starts moving in the forward direction with some velocity. Understand? Okay. Come on. Okay, there are two people, so I need to pay 1,000. Huh? Okay. I'll pay you 1,000. Don't worry about that. Follow the same question. If the person starts increasing the speed, once again he increased the speed and he observes rain again falling at him at the same angle 30 degrees. What is his new speed? With 20 meters per second again falling at him, what is his new speed? Come on. Till then, follow this one. So can I say basically in this case over here, this is the velocity of rain with respect to man, because this is vertically downwards. When is he observing? When he starts moving. That's why velocity of this. Now you need to find which velocity of man with respect to rain. This is a vector question. Parallel shift of vectors. Shift this vector over here. Can we shift this vector over here? We say velocity of man. Understand? Now in this case, can you tell me sine of 30 degrees? Say perpendicular upon hypotenuse. Sine of 30 degrees is nothing but this perpendicular upon this hypotenuse. You will say Vm upon hypotenuse is how much? That is 20 given itself. So can I say sine 30 is 1/2, I guess. Okay. So Vm by 20. So Vm will be nothing but 10. Okay. Vm is nothing but 10 meters per second. So this person has to move with a velocity of what? 10 meters per second. Understand? Fine. This person has to move with a velocity of 10 meters per second. He will then observe that rain is falling vertically downwards. So this was the question. Okay, I'm waiting for the next question's answer. How much that will be exactly? Come on. Now, let's go for this one. Okay. I cannot expect the answer from you people. Let me just follow this. So now he is saying that same scenario is happening. Okay, I'll just draw the same figure. Okay, I'll just draw the same figure. Initially, this was the velocity of rain with respect to man. Understand? So when basically this man was exactly at rest, he was observing that velocity of rain is 20 meters per second. Okay, fine. And when he starts moving with a velocity, I would say how much? 10 meters per second. He observes that rain is falling vertically downwards. Okay, initially it was at 30 degrees. So now what happens over here is, I'm asking you, I'm basically telling you that the person basically increased the velocity once again. Understand? He was moving with 10 meters per second velocity of man. So he was observing that the rain is falling vertically downwards. Now he starts moving once again. He increased his velocity. He increased its velocity in such a way, he reached the value of velocity so that the rain will now again appear at 30 degrees with the vertical, with same 20 meters per second. Now what is his new velocity? Let me just make you understand. So if I, for example, draw it in a vector form as well, so can I need to basically make this large now. Okay, I'll increase this exactly. I'll increase this vector exactly. Okay, I would say this is velocity of man because he increased his speed. Okay, fine. Now, what is he saying? That again, it appears that the rain is falling vertically. These are actually equal sides. Okay, at what? That is 30 degree with vertical. 30 degree with vertical at what? That is 20 meters per second. This is once again saying that this is the situation over here. Now you tell me one thing. We need to find this V of M. This is new V of M. Forget about 10. V of M. Yes, GTA Rani is saying 20. So you are 10,000. Okay, I'll pay you. So now the scene is this is basically 30 over here. Solve it with the vector method. This is 30. Can I say if this is 30, this is total is 90, this is 60, 100%. 30, this is how much? This is 60. Understand? Because total is 90. This is 60, this is 60. Total 120. How much will be the third angle? Total is, sum is 180. So this will also be 60. Can I say this is the equilateral triangle? 60, 60, 60, 100%. So this side is basically 20. This side is basically 20. I'll just write it over here. This is nothing but this side is 20. If this is 20, this is 20. Third side will be also 20. So this will be also 20. So can I just say directly that the new speed will be 20 meter per second? He has to move with 20 meter per second. Understand? He has to increase 10 meter per second once again, so that it appears that rain will fall at 20 meter per second at a 30 degree with the vertical. So new speed is 20 meter per second. Fine. Yeah, you will be getting all the old videos, okay? Chill scenes. Now, see, the rain is falling at 20 meter per second with respect to ground. Understand? At a 60 degree angle with the horizontal. Understand? The man starts moving with 10 meter per second. Find velocity of rain with respect to man. Come on, I'll tell you what this question exactly says. It says that the rain is falling at 20 meter per second. So this is falling at 20 meter per second with the horizontal. Okay, I'm saying this is horizontal. How much? 60 degrees, making 60 degrees with the horizontal. Understand? The man over here, he starts moving with a velocity of 10 meter per second. Now, this was the initial scenario. When the man starts moving with 10 meter per second, we need to find the velocity of this rain with respect to man. It's very simple. Velocity of this rain with respect to man, we need to find now. Can we say this is nothing but velocity of rain with respect to ground minus velocity of man with respect to ground? 100%. So velocity of rain with respect to ground, we need to find right now. Now, can you tell me what will be the velocity of man over here? So you will say, velocity of this rain with respect to ground. So if the person over here, he will observe that this is the velocity of rain with respect to ground, 60 at 60 degree angle, 20 meter per second. So can you resolve this in two vectors? So this will be first like this. This will be second like this. Understand? So can I say this is nothing but it will be 20 cos of 60 degrees, and this will be nothing but 20 sine of 60 degrees. Okay. So how much it will be? I'll just write it. How much it will be? It will be 20 into root 3 by 2. So it will be 10 root 3, and it is in the downward direction. So j cap, and it will be negative j cap. Okay. So this is in the backward direction. It will be nothing but cos 60 is 1 by 2. And this is 21 by, this will be 10 I cap, and that too in the backward direction. Fine. Now you need to draw this. That's all. Okay. So velocity of rain with respect to ground. So first is downward. One of its components is in the downward direction. Other one is that in the backward direction. So can I say that is nothing but minus 10 I cap. Okay. And this, yeah, exactly. And this will be nothing but how much this will be? It will be basically 10 j cap. Come on, I need to know the answer in the live chat over here. So basically what I exactly did, this is the velocity of rain. Understand? This is the velocity of rain over here. This is the velocity of rain over here according to the ground frame. So we basically resolved this in two components. Why did we basically resolve this in two components? Because we have to find exactly according to the vector method only. We have to find the magnitude of that one only. That's why we are saying in this case, we need to exactly do that. Come on, in the live chat, can you hear me? Can you basically understand this question? I need to know. Please don't stop your lectures for those old videos. Yes, we won't stop the old lectures for the old videos. Don't worry about that. Chill scenes, brother. Everybody able to understand? Come on, I need to know in the live chat over here. Yes, feel is mandatory, okay? In order to get the feel of physics, you have to compare the concepts with the real life situations. That's why. And most importantly, if you want the feel of any of the concepts, you basically should first ask the question to yourself, why are you studying this concept, okay? Then only you'll get the real feel of that concept. That's mandatory in physics. Because if you keep on understanding the concept, if you keep on learning the concept without understanding this fact, that what is the application of this concept in the real life, then means you are not getting the real feel. Okay. That's the point exactly. Next topic will be reverse swimmer problem, okay? That we need to find. That we need to go for. See, best book for physics, it completely depends upon the person, understand? Like if you are exactly starting from very basics, entirely basics, I suggest you to start with the book like this Halliday, Resnick and Walker, because that gives you the good explanation of understanding the concepts if you really want to understand the physics, okay? So apart from that, you should go for the IC Verma as well, understand? So once you understand the concept from that basic point of view, try to understand it from the IC Verma as well. So, and solve the conceptual problems from IC Verma, because in IC Verma, it basically tells us how you can understand, how you can basically apply the theory in practical problems, okay? So that's why it is mandatory. So once you get done with that, afterwards you need to move on to some other books, and there are some other coaching material also, like on Unacademy Plus and Iconic, you'll be getting weekly tests, mock tests that are mandatory, highly mandatory, okay? So that is very important. And like you can go for that Singh or BM Sharma. That book is also very good because that is having the categories of problems. So you can go for that as well. Definitely. Thanks. 1 second. I need to basically switch this. Okay. There is this inverted problem. Yeah, it's done now. Okay. Okay. Now let's go for this one. So what I was explaining you. So this is basically what is happening over here. So this is the velocity this is the rain that is falling on this person exactly. Okay. So this is moving with the 10 meter per second itself. And in this case, this velocity will have two components. This is the first component. This is the second component. This will basically when we basically resolve this in two components, then we draw the vectors of this one. Now finally, what we are supposed to find the velocity of this man. Understand? So according to this man only, so this I will get cancelled with this one. Understand? This will get cancelled with this one because for this it will appear in the same direction clearly. Okay. So it will be exactly this one. So from this we can clearly get velocity of this rain with respect to man. This 10 will get cancelled with that one, and we'll exactly get this 10 root 3 j cap exactly, and it will be in the downward direction. So according to this person, it will fall. According to this man, it will exactly fall in the vertical direction. That's what. Let's move on to this one now. Okay. So these were the basically easy problems, not that difficult. Okay, not that difficult, but I suggest you, okay, this still they are having the good level. In your JEE exam, they will ask you something like this only, okay, but I suggest you people to join me. Okay, so yeah, electromagnetic waves, it will be on tomorrow, day after tomorrow. I'll be basically giving you that day after tomorrow. So now see, I suggest you people to join me tomorrow at 6 o'clock, okay, 6 p.m. exactly, at on special classes, and over there we'll be solving some of the previous year questions, best questions. You'll be definitely loving it, okay? Sir, how can I watch the video again? It'll be uploaded as a recorded one, okay, once we are done with the live stream. Okay, are you first time on the YouTube, bro? Okay. It's gonna be okay. It's gonna be okay. Now, ladies and gentlemen, boys and girls, listen to me very carefully. Now, we'll be talking about riverboat or river swimmer problems, okay? This is also problems. In this one, see, there will be a river, okay? We need to cross that river, okay? We need to cross that river. If I ask you the question, how much time it is gonna take you to cross that river? This can be asked, understand? How much time it's gonna take to cross that river through the shortest path? They can ask this one. Or they can ask, what is the shortest path? Understand, is this if this is a river, understand, if this is a river, is this the shortest path, this is the shortest path, this is the shortest path, and if you travel through this shortest path, how much time it's gonna take, and what is the velocity of this boat, what is your velocity with respect to this, what is your velocity with respect to this ground, water, at what angle you need to basically move in order to cross the river. These are the questions they'll be basically asked in this one. That's why we say riverboat. This is not the concept, problems only. This is the application part of relative velocity in 2D, like Rain Man problems. That's all what we need to discuss over here. So first, I have basically divided this in certain number of cases. The first case basically is, this is what we call the still water. Still water, understand? So water is still means ruka hua water. In this case, velocity of water is 0. The water is not flowing, understand? See, I'll make you understand. The water is not flowing. If I say, for example, this boat is moving in the forward direction, velocity of this boat, okay, is nothing but 10 meter per second. One second. So if I say, for example, this boat is moving with a velocity of 10 meter per second in the forward direction, okay, in still water. So what can be the question? What can be the question over here? If I ask you, there is a person sitting over here on the ground. According to this person, what is the velocity of this boat? You will say, sir, velocity of boat with respect to this ground, who is exactly at ground. So this person is observing this boat. This boat is moving with a velocity only 10 meter per second. There is no other velocity because water is at rest. Water is not dragging this boat. So water is at rest. So water is having 0 velocity. So according to this person, this is only having 10 meter per second. So it's moving with 10 meter per second. So that will be 10 meter per second only. Understand? Now the point is, there is another person who is exactly inside the water. Understand? Now if we ask this person, bro, you just tell me, according to you, how much is the velocity of this boat? He'll say, I am exactly in the water and water is having 0 velocity. I am at rest. So according to me also, this boat is having only 10 meter. So it is dragging. It's getting dragged. Still means rest. Yeah, still means rest. Still water. Rest water. Okay. So according to this person, it is saying that this boat is also moving in right direction with 10 meter per second. So according to this person also, that he is in the water. So velocity of boat, this boat with respect to water also 10 meter per second yahan pe clearly. So this is the normal observation. You can find it with the what? Relative velocity method also. You can use the relative velocity method also over here. So what is that? So we say velocity of boat with respect to water. You will say velocity of boat with respect to ground minus velocity of boat with respect to velocity of water with respect to ground, velocity of this water with respect to ground. So can we say how much is the velocity of this boat with respect to ground? That is 10 meter minus velocity of this water with respect to 0, 10 meter. Either you use relative velocity method or you do it with the normal observation, you will get the answer. Okay. The case number 2 over here is, I'll move with a faster, more speed. Okay. The case number 2 exactly is what we call the, let's take the downstream. Okay. Down. What is this downstream? Means in this case, water is flowing. Understand? Water is flowing. So, for example, this is water. Water is flowing in this direction, downward direction. Now, if the water is flowing in the downward direction, I would say velocity of water over here is 5 meter per second. And boat is also basically what do we say, driving, going in the downward direction in this water with, I would say, velocity of boat over here is 10 meter per second. Understand? This is water, this is velocity of boat. Now in this case, if I ask you the simple question over here, listen to me very carefully, okay? Yeah. Water, if I say river, okay, it's one and the same thing, okay? Consider it same thing. River, velocity of water, understand? It's one and the same thing. Don't confuse yourself. That's why river boat problem, or if I say boat, even if I say swimmer, one and the same thing, okay? I'm basically, yeah. Don't confuse yourself. These are very simple things, okay? Why are you confusing yourself? Now see, if I say, for example, velocity of this boat with respect to ground, how much that will be? So if the person is exactly over here at the ground, according to this person, this boat will have two velocities. One of its own 10 meter per second, another that the velocity of water. So water is basically dragging it now. So if this boat is having no velocity, so it will still basically go, it will still flow with the velocity of water, because velocity is dragging it with the velocity of water, that is 5 meter per second. So according to this person, it will have two velocities, 10 plus this 5, that is 15. So can I say that is 15 meter per second? 100%. Now, if I say, for example, there is another person who is inside the water. So according to this person, this boat will have only one velocity, that is a 10 meter per second, because 5 meter per second, this is also having, because he is also inside the water. That's why it is something like this. This is a truck, okay, that I gave you the previous example. This is moving with, for example, 5 meter per second, okay. There is this car, okay, on this truck, which is moving with 10 meter per second. If I say, for example, this person over here, this person will basically say this car is having only 10 meter per second, that is towards me, because 5 meter per second, he is on same bus, he is on same truck. He is also having 5 meter per second. This is also having 5 meter per second. So forget about that 5. So extra velocity of his own is a 10 meter per second. But if there is a person on ground, according to this person, he is having 10 plus this 5, that is 15. Clear? Is it clear to everybody over here? Yes. So can I say in this case over here, so according to this boat, according to this person will have how much velocity of this boat with respect to this person, or with respect to this water, river, whatever you say, who is inside the water. So that will be only that 10 meter per second, 100% only 10 meter per second. No velocity than that. Okay. Okay. So that's all. So now the point over here is, we can basically use the relative velocity method also in order to calculate this one. You'll say, sir, how? Okay, see, velocity of this boat with respect to ground, okay, with respect to water. Let's find the with respect to water first, river, water. Can you say that is velocity of this boat with respect to ground minus velocity of water with respect to ground? Now you tell me one thing. How much is the velocity of boat with respect to ground? With respect to ground, it is having 10 plus 5, that is 15. That is 15 minus velocity of water with respect to ground. How much that is exactly? That is this 5. So velocity of boat with respect to water is nothing but 10 meter per second only. Same goes for this one. You can find this also. That is velocity of boat with respect to ground. How much that will be? So that will be this plus this. Take it over there. So velocity of boat with respect to water plus velocity of boat with respect to ground. So it will be nothing but velocity of boat with respect to water, that is 10, plus velocity of water with respect to ground. Velocity of water with respect to ground, that's 5 only. So it will be 15 meter per second. Fine. Now the case, another case is basically, that is, we call the upstream. Understand? So in this case also, water is flowing in the downward direction, okay? I am on this channel since the beginning, okay? So in this case also, if I say this is velocity of water, I would say 5 meter per second. Fine. And this boat, if I talk about this boat, now in this case, this is upstream. So boat is basically moving in the opposite direction. The water is still flowing in the downward direction, but boat is moving in the upward direction. That's why we say upstream case. So we say velocity of this is nothing but 10 meter per second. We say this is velocity of boat in this case. Velocity of boat is 10 meter per second. Now, can you tell me in this case, velocity of this boat with respect to ground and velocity of this boat with respect to this water exactly? Come on, in the live chat, I'm waiting for your answers. Come on. Now see, velocity of this boat with respect to ground, how much that will be? For example, there is a person over here. He is observing this boat. This boat is basically being dragged by this water in the downward direction with how much velocity? 5 meter, because this water is flowing in the downward direction with 5 meter per second. And this is having its own velocity, that is 10 meter per second, but in a negative direction. So this person is saying that negative 10 plus 5. Negative 10 plus 5. How much? Negative 5. Understand? So this means from this side is having 5 meter per second. Because of this water, it is having this 5 meter per second plus 5 meter per second. So this is negative 10. So 10 minus 5 according to this person. So this is moving according to this person. This is moving in the rightward direction with how much velocity? Minus 5 meter only. So this is minus 5 meter per second only. Understand? Now if I ask you velocity of this boat with respect to water, how much that is? Tell me. How much that is? This is the point. Yeah. Tell me velocity of boat with respect to water, how much that is? See, if there is a person over here, according to this person is having 5 meter per second. This boat is having two velocities. One of its own, that is negative 10. Another is 5 meter per second because of water plus 5. So this is saying that he is also having 5. I am also having 5. So what is the extra this guy is having? That is 10 meter per second. That too negative 10 in the left direction. So negative 10 meter per second in the left direction. Understand? So this is the case. You can find this by using the concept of relative velocity as well. So that is velocity of this boat with respect to water is nothing but velocity of boat minus velocity of water. Now velocity of this boat is how much? Velocity of this boat is how much? Velocity of this boat with respect to, this is with respect to ground. Ground. With respect to ground, it is clearly, that is how much? Minus 5. You can clearly say minus 10 plus 5. That is minus 5 over here. And minus velocity of this water with respect to ground. This water is having velocity only 5 meter per second with respect to ground. So this negative and this will be minus 5. So it will be negative 10 that we got over here. Same goes for this one. We can find this also with the relative velocity method. Yeah, this is the concept that we are using over here. Fine. It is something like, I'll give you the another example for this one. For example, this is the same truck. Okay, this is the same truck. This is moving with 5 meter per second. Okay, there is a car, okay, on this truck exactly. This car is moving with, for example, in the opposite direction of 10 meter per second. Now if the person is exactly on this truck, according to this person, he is saying that he can see that, he feels that this car is only going away from me with how much? That is 10 meter per second. So according to this car is having only minus 10 meter per second. But if the person is exactly at ground, he can imagine that, he can feel that, he can observe this situation. Truck is moving in the forward direction with 5 meter per second. Car is moving in a backward direction with minus 10. So according to this, it is minus 5 meter per second only. Yeah, great. Now there are some things we need to basically find out over here, then we get done with this. We don't talk anymore like we used to do. Na, 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 na. Everybody understood? Come on. I just need to know in the live chat. Crossing time. With what velocity he should cross the river? For example, there is a river. Okay, there is a swimmer over here. Now we'll take this swimmer, not the boat. Okay. So swimmer wants to cross the river. How much time he's gonna take in crossing the river? And how much will be the drift? I'll tell you what is drift exactly. With what velocity he will basically cross the river. What will be the velocity? Net velocity, okay? Everything we're gonna be finding over here. Yes, claro. Okay. Now see how we can basically go for this one. I'll tell you exactly. For example, I am saying that I started from this one. I need to cross this river. First of all, we'll find basically how much will be the velocity, net velocity over here. So I'm saying that, for example, I started crossing this river. I started at this angle, for example, in this one, understand? So what is drift basically? I'll tell you drift also. So I started with this velocity. So this is basically the swimmer. Now I am taking swimmer. So this is velocity of swimmer, understand? So this velocity will definitely have two components. So first I can say this component, another one I can say this component, understand? So for example, I am saying that with the vertical it is making that theta angle, understand? This is theta. Can I say this component will be nothing but Vs cos of theta, and this will be nothing but Vs sine of theta. And this river is basically flowing with the velocity of water, understand? This is the velocity of river or velocity of water. You getting me what I'm trying to say? This is basically what I started. I have to basically, this is the river given, okay? I need to cross this river. How much amount of time I'll take in crossing the river, I need to find that. Second thing is with what velocity I'll cross, I need to find that. How much will be the drift I'll explain after some time, okay? Fine. So basically this is the scenario over here that is happening. I'll cross this one. So can I make the final velocity diagram? This is having velocity, this velocity, this velocity, this velocity. I'll make the net velocity diagram, okay? So I'll make it something like this. Okay, so velocity in horizontal direction, we resolved this in two components. Velocity in horizontal direction, I would say that is simply this Vs cos of theta. I would say that is simply this Vs cos of theta 100%. And velocity in this direction, can I say this velocity in this direction? Now tell me how much will be this velocity in this direction? Can I say, see, this is a velocity of water, understand? It will drag it, it will drag this person. If this person will basically go like this, it will drag it towards right, because the flow of water is towards right. So it will drag it, it will drag it, understand? So can I say that in this case, this will be the velocity of water, this will be more as compared to this one, definitely. So I can say definitely this will be Vw minus Vs sine of theta in that case over here. So can I say how much? This is the velocity in horizontal direction. This is in horizontal, this is in vertical, something like that. You find the net of this one, understand? So can you tell me how much will be the net velocity in this case? Okay, so now can you tell me how much will be the net velocity in this case? You are saying that only V cos of theta? That I'll tell you after some time, okay? What is that exactly? In what case we need to exactly use that? Hold on for some time. Now you just tell me in this case, can I say how much will be this net velocity over here? That will be nothing but a root of this square plus this square. That is Vs cos of theta its square plus this Vw minus Vs sine of theta its square. I'm basically making, I'll tell you every case, okay? I'll tell you every case so that you can solve all the problems, okay? Every damn thing. Once we get done with this, no confusion will be left for sure, okay? Now, if I ask you how much time it's gonna take you to reach from this point to this point, you'll say, sir, time is nothing but how much a distance I'll cover from this point to this point. So you'll say how much distance I'll cover. For example, if I say this distance is d, so time will be nothing but this distance upon with what velocity you will cover. You'll say, sir, I need to cover this distance only. I need to cross this distance. I'll take this one, okay? So that is nothing but Vs cos of theta. Clear? Fine. Now the point over here is, sir, what is this drift? See, if you cross this river, if you try to cross this river, this will basically, river will basically take you towards itself. Understand? Towards with a river only, because that is flowing in the right direction. So you will drift. You will not exactly reach this point exactly. So you will drift. Understand? If you start traveling from this point to this point, if you cross this, for example, so you'll get drift. You will drift. So how much will be that drift? For example, you were supposed to reach over here. You reached over here. So this will be the drift. I call this as a drift. Now, how much will be this drift? It is very simple. We can definitely find this. So can I say this drift x will be nothing but velocity? With what velocity you basically did this drift? That is horizontal velocity. How much is horizontal velocity? This much velocity into time, velocity into time. A distance you are supposed to find over here. That is distance is velocity into time. Displacement is velocity into time. Velocity with what velocity? This drift actually happened. Can I say this with this velocity? And you said, sir, with this velocity, we want to basically cross. Go for this one. So can I say that is velocity, that is VW minus VS sine of theta multiplied by time, You'll say, sir, now we need to basically add this one also. So can we just write this drift will be nothing but VW minus VS sine of theta. Time is what? Time is how much? See, you will say, can we put this time over here? Because see, if you, for example, go from this point to this point and you will eventually reach this point. So in crossing this, if you are taking this much of time, in the same time, you will do this drift only, na? Because all this process happens in the same time. If, for example, you are taking 10 seconds in crossing the river. So in that 10 seconds, you did this drift as well as you crossed the river. So it's one and the same thing. So I can use, instead of this time, I'll just write d upon this Vs cos of theta. Any confusion in this one? Come on, I need to know in the live chat. Any confusion in this one, or everything is clear? I'll make you understand this once again. Come on. Now I'll move on to the next one then. That's great. That's great. Crossing the river, I told you, I'll tell you all the cases, every single case, okay? Crossing the river in shortest time. Now you need to basically cross this river in shortest time. Understand how you can do that? Now a lot of people might be thinking over here, sir, if we cross this river with the shortest path, we will be basically taking shortest amount of time. It completely depends upon us. We take, see, if you find in every book, okay, you will basically find we take basically theta from this only. Understand? For the calculation purposes, it is not, you can basically take it in that way also. In some books, you can find it in that way also, because I am taking in this way also, not a problem. So this is theta. Basically, we measure the theta from this only. Afterwards, you will be giving the question at what angle you need to basically move so that you will move, go with the shortest path. It completely depends upon us. If that was your question. Crossing the river in the shortest time. We need to basically cross this river in shortest amount of time. You will say, sir, if we cross this river with this shortest path, then we can basically, yeah, you basically, see. In order to solve the questions, I suggest you to take it from here only. So you measure the theta with this only, understand? So from this only, because in every book, most of the books, it is given like this only. Because what is this? You are measuring just theta. Completely depends upon you, okay? With what you are taking. Now see, main and important point is, I'm saying, okay, over here, crossing the river in shortest time is 100% okay? Crossing the river in shortest time, crossing the river with the shortest path, 100% it will take a short time. Let's see. So basically, if you want to cross this river with shortest distance, with the shortest path, means this path, means river is flowing in this direction, so it will drag you. It will create the drift. It will create the drift over here. Now, if you want to basically go through this, see, there are two cases. First one is, if you, for example, started this one and you started going directly towards this, it will drift. It will basically, there will be drift. It will drag you and eventually you will reach this point. So you didn't basically move with the shortest path. Shortest path was if you have traveled through this path only, So you started traveling through this path. But what happened? The river took you with it. Understand? I have no idea about that. What are you talking about? Chitna, yeah. No idea, bro, about that. Yeah, perpendicular distance is this. This distance. Now see, yeah. So basically, if you start with this, so you won't basically travel through the shortest path. Now the point over here is, how can you travel with the shortest path? You already have to move with at some angle. When you travel through some angle, for example, at this angle, you started with this, it will drag you, eventually you reach from this point to this point. Then it completely depends upon us how much should be the angle that we'll find the value after some time, how much should be the value of that angle, so that we'll travel through this shortest path. That is the point main. So first point is to understand over here is we need to basically move at some angle initially. So this is the angle that we need to move initially. Fine. Okay, we'll go with this one. So this is Vs. So Vs will be having two components. So this will be having two components. That is Vs sine of theta, and this will be having Vs cos of theta. And this from this side is nothing but this velocity of water. You tell me one thing. If you people are saying right here that, sir, we'll go with the shortest path, okay, we can take shortest amount of time in that case. But I'm saying that when you go with the shortest path, you have to move at some angle. So this velocity will have two components, this one and this one, cos 1, sine 1. Now, if you want to travel through the shortest path, you have to kill this velocity, which is in the right direction, velocity of this water, velocity of this river. Because when you kill this velocity, so you will definitely travel from this point to this point in the shortest path, Do you think you are traveling from this point to this point with complete velocity, with all of its velocity, original velocity? Definitely not, because half of your velocity is killing this velocity, so you are moving with less velocity. So how will you reach from this point to this point in shortest time? Definitely you will basically move in the shortest path, but you will not take less amount of time. How many of you understood this concept? Come on, how many of you people understood this concept, what I am trying to say? Then I'll tell you how we can basically get the shortest time. Are you getting me what I'm trying to say? Now see, I'll tell you, okay? So basically what I'm trying to say is that if you want to travel through the shortest time, I suggest you to use your entire velocity through this point only, through this line only, understand? Through this line only. So that is Vs. You use all of your velocity through this only. So afterwards, you will basically drift. There will be the drift, but you will reach within a shortest amount of time. Why is it like that? It is something like, for example, you want to travel from this point to this point, understand? So there is so much of traffic through this road, so much of cars are in between, so much of traffic. And if you will travel through this road, you have to basically move with a less velocity. So there is another route also. This is bypass. Will you travel? There is no car over here. You can definitely go with the speed of light from this one, okay? 100 kilometer, 200 kilometer. Will you prefer this path or this path? Definitely this path. So this is a distance is large, okay? Same is the case over here. Distance is large, but in this case, velocity is more. When velocity is more, you will basically reach in less amount of time. From here to here, it will take you hours. Why? Because in this case, there is so much of traffic. Distance is less for sure, but traffic is so much. So velocity will be less. Same is the case over here. One of your velocity component is killing this velocity. So you are only moving with half of the velocity, less velocity. So how can you reach point B in shortest time? So that is my point. That's what I wanted to basically explain you people. Now see. So what we are supposed to do exactly, I am saying that you use all of your velocity through this one, you will get basically, so you will be drifted. Drift will be there, but you will reach in very less amount of time, shortest time. Now, let's go with the formula. How much was the formula previously? T is equal to d by cos of this much amount of time is taking from this point. This is general formula. How much time it's going to take in crossing the river? T is equal to d. If I say, for example, this distance is basically d by Vs cos of theta. Now, if you want this term to be minimum, you have to make this term maximum. Understand? How you can make this maximum? Put theta is equal to 0. Value of cos will become 1. Understand? Cos theta 1 maximum. So if this becomes maximum, this will become minimum. Very easy. So if theta is equal to 0 degrees, means cos of theta will be what? Cos of theta will be what? That will be 1. If cos theta will be 1, so t will be nothing but d by, that will be maximum, because value of this eventually depends upon cos of theta. Understand? So over here, can I say this will be d upon Vs? Cos 0 is 1. So this will be the minimum time. This will be the minimum time. That's why I told you, you complete use Vs through this path only, through 0 degree only. When theta is 0, we measure the theta with this one only. When theta is 0 means you along this path only. So in that case, Is it fine now? You understood? There will be full concept videos, will be coming up with the entire syllabus. Okay, now don't keep on asking the same question, Gautam. Okay, we'll give you every content. By the next 3 months, the whole syllabus will be completed. Don't worry about that. Sir, you are making concepts crystal and clear. Yes, that is the goal of, that should be the goal of a physics teacher. Okay. Okay. Ria, not able to understand. What are you trying to say? See, basically, we have to basically use all of our velocity through this only. Means completely, you started traveling with this shortest path only, through this path only, not the shortest path, through this path only. Eventually, what will happen? This will drag you towards a right. Okay, fine. Not a problem with that. So you will reach this point, but in very less amount of time, because you are using all of your velocity in crossing the river only. Understand? So you are not using any of the component of your velocity in killing the velocity of the water. So that's why. So over here, I proved with the equation itself also. That's why we got the time. So you got the feel of this equation? Come on, I'll move on to the next one. So this can be the minimum time. If you want to reach from this point to this point, cross the river in minimum time, you have to use all of your velocity along this only. That's why we got Vs along this only. Complete Vs, use along this only. When theta is equal to 0 degree, then you will basically get this one. Crossing the river by shortest path. Okay, crossing the river by shortest path. Case of zero drift. Understand? Zero drift will be when you go from this point and you will reach this point. Drift will be when you will be drifted. When you will be drifted. Understand? When you will be dragged by the water. Okay. That is the point now. This is the case number 5. Yeah, this is the, I guess, last case. Yeah, this is the last case, and afterwards we have 2-3 problems, then we are done with the lecture. Now see what I am trying to say. So if you want to basically cross this river with the shortest path, so what you are supposed to do, you have to already move at some angle. So this will drag you, this water will basically drag you, and you will basically reach from this point to this point. We have to find at what angle we need to basically go, at what angle we need to basically start, so that we'll reach from A point to B point completely. Understand? So if I say, for example, we started moving at an angle of theta. We need to find the value of this theta. And with what velocity you need to travel from A to B, time, everything I'll calculate, okay? Not a problem, okay? Now the point over here is, listen to me very carefully. Listen to me very carefully. So, for example, you started with this one. Can I say, if you started with this one, can I say this is Vs? Okay, so Vs will have 2 components. So this is basically one component, that is Vs cos of theta, and this will be nothing but Vs sine of theta. Vs cos theta, Vs sine theta. Fine, chill scenes. Now this is the velocity of water. As I told you previously, if you want to travel from this point to this point along a straight path, you have to kill this velocity. How can you kill this velocity? One of your component will kill this velocity, so that this velocity will not drag you towards the right, so that you will basically travel from this point to this point in a straight path. You're getting me? So you don't have to confuse yourself. Just remember one thing. I'll show you all the problems by solving this method only, with this method only. Okay. So what you are supposed to do is, you take the theta with this vertical only. Okay. So basically, are you confused? Then your vectors is basically weak. So if, for example, this is theta over here, if we say this is a vector, okay, this is a vector. If I say this is the theta, which component you are supposed to take as cos theta, sin theta? Is that your question? See, if, for example, theta is this side, understand, means not this side, from, you have to take cos in along that which is basically nearer to this theta. You can say, understand it like that. So this is nearer to this theta. For example, over here, this is, for example, I would say u. So this will be nothing but u cos of theta. And this will be nothing but u sine of theta in this case. Now, if I say, for example, it is something like this, this is theta. So in that case, nearer to this component, this will be one component of this one. So you will take this as cos theta. That is nothing but u cos of theta. Why? Because this is nearer to this theta. Cos component has to be with theta only, and the other component, this is basically sine of theta, that is u sine of theta. Is this your question you are asking? Yeah, this is the vector question that you were asking. Yeah, depends upon the angle. Understand? Depends upon the angle. That's why I'm saying, if we take this as theta, then you take this cos theta. If we take this as theta, then you take this cos theta. So you have to basically stick the cos theta with the angle itself. Come on, listen to this now. Listen to this now. All of you. Now see, so what I'm trying to say is that now in this case, can we say that clearly this is a case of drift? This is a case of zero drift. It means you travel from this point to this point. So in this case, this velocity will kill this velocity. Means this velocity has to be equal to this velocity. Then only it will kill it, because both are in the opposite direction. So you will travel from this point to this point clearly. So in this case, can we say V of W is nothing but V sine of theta, Vs sine of theta? Clearly, how many of you understood? Now, you got this now, okay? Why did I write this VW is Vs sine of theta? Because this velocity has to be equal to this velocity. It will kill this horizontal. This rightward velocity will kill leftward velocity. Then you will move along this direction from this point to this point, okay? In this case. Now, you tell me one thing. How much can you find the value of this cos theta, Vs cos theta, with which you are traveling? If you are basically going from this point to this point, with what velocity, my dear brothers and sisters, you are traveling? You are traveling with Vs cos of theta only, because Vs sine theta is killing this one. It is basically equal to this one. So they will kill each other. You are traveling with Vs cos of theta. Find this Vs cos of theta, how much it is. You will say, sir, it is very, very, very simple. You Kashmiris are making it difficult. Okay. Now, so can I say this Vs is basically this component plus this component? So Vs, this Vs I'm writing, that is a root of this component plus this component square, Vs sine of theta, its square, plus Vs cos of theta, its square, 100%. Okay. Now, the point over here is what we are supposed to do exactly. Can you just tell me Vs sine theta is what? Vs, this one. So Vs is equal to root of Vs sine theta is equal to, in this case, that is Vw. So that is Vw square, plus this will be Vs cos of theta, its whole square. Now I need to find this Vs cos theta, because we are traveling through this velocity only. Find velocity with which you travel through A to B. That is Vs cos theta. That's what we are supposed to find over here. So now take this root over here. So can we just write Vs cos of theta, its square is nothing but, if we take the root over there, it will be nothing but Vs square minus this Vw square. So this Vs cos of theta is nothing but a root of Vs square minus Vw square. Fine, we got the velocity also. Now the question is time also. Not a problem, we'll find the time, how much time it's gonna take basically. So with what velocity you are traveling this? If I said this distance is basically how much? This is a d, okay? And this distance is b. So tell me the time. You will say that is a distance upon with what velocity you are traveling. So can I definitely say d upon this Vs cos of theta? So it will be nothing but d upon this root of Vs square. The question on this equation was asked in IIT JEE 2010. I'll tell you, I'll show you after some time. So Vw square. Fine, you got this one. Okay, there is one more thing. Okay, I'll just add the slide. Now what we need to exactly find out is now what we need to exactly find out is the theta. At what theta we need to basically move. We got the velocity. With what velocity we need to travel. How much time it's gonna take from A to B. Third thing is that we are supposed to find out is basically at what theta. It is very simple. So can we use basically say this is sine of theta is how much over here in this triangle. If we say this velocity of water, if we can parallel shift this vector over here, okay. So it will be something like this velocity of water. So how much this will be? This is Vs. This is one vector Vs. This is theta. Velocity sine of theta will be how much? Perpendicular upon this hypotenuse Vw upon Vs. Can we say it like that? So this will be Vw upon Vs. Understand? Theta will be sine inverse of this one. So got this one. You can basically find this with the other method. Alternative also. What is the alternative? Let me show you. See, can we say this is a case of zero drift? 100%. Now, what was the drift? Formula for drift? Formula for drift, how much drift will be there? As if there is zero drift, we'll put it equal to 0. So take this drift. That is x is equal to Vw minus Vs sine of theta into t. How much time it's taking? That is x is equal to, that is Vw minus Vs sine of theta into this t. Fine. As if this is a case of zero drift, because you are traveling from A to B directly. So drift will be 0. So this will be Vw minus Vs sine of theta into t. T cannot be equal to 0. So this has to be equal to 0. So Vw minus Vs sine of theta is equal to 0. Can we just write sine of theta is nothing but Vw upon Vs. Okay. That's all. You don't have anything in this one. Okay, there is one more point, that is this. If you want to basically cross this river, I have covered every damn point in this. Okay, if you go basically search in any of the books, these points, there are some points you will find it over there, but I have covered every damn thing. Okay, you will be able to solve every question from now onwards. Okay, now Vw is less than Vs. Then only you can cross the river. Why is it basically like that? So it is saying that this is the velocity of river, velocity of water, okay, in the right direction. Okay, this is the velocity of water in the right direction, and velocity of swimmer is basically something like this. I would say velocity of swimmer is something like this. So what the question is saying, what this point is saying, velocity of water has to be, this has to be less than this one, or it is basically you have to move with a greater velocity than the velocity of water, then only you can basically cross this river. It is very simple. It's common. Okay. Now see, let me just tell you why. See, we got this relation over here, that is sine theta is equal to Vw by Vs. Sine of theta is equal to Vw upon Vs upon Vs. Now, if I say, for example, if V of S is equal to V of W, means this velocity of water is equal to the velocity of swimmer. If that is the case, what's going to happen? So this is equal to this. So they will cancel. It will be 1. So sine of theta is 1, means theta is equal to 90 degrees. Theta is equal to 90 degrees means we measure the angle with this one. For example, with this one, we say this is theta. Theta is equal to 90 degrees means this is the vertical. We measure the angle with this one. Okay. 90 degrees means you basically move it like this, because this is the only 90 degrees angle. Means in that case, if Vs is equal to Vw, velocity of water is equal to Vw, means you are traveling like this, Vs, and this is Vw. Do you think you would be able to cross the river? Definitely not. No. Why is it like that? Because you are just moving opposite to the direction of water. So in that case, you cannot you cannot cross the river. Why? Because you cannot cross the river. You are just moving upwards. You have to move something like this only. So what is the next point? Next point is if this Vs is less than Vw. Now see, from this equation only, if this Vs is less than this Vw, if this decreases, theta, sine theta will increase, means theta will increase, because value of sine theta depends upon this theta. So eventually in that case also theta will increase. Understand? So theta has to be less, then only you can cross the river. So theta will basically increase more. So it is not possible for you to basically cross the river. So that's why it is mandatory. You have to basically go like that. It is very simple. If you to understand this from the logical point also, there is a water that is flowing. This having a large amount of speed. You are having very less speed. Do you think you will cross? It will basically take you with itself. Understand? So that is why you need to have some greater velocity and that should be more than the velocity of water, then only you can cross the river. That is mandatory. Okay. So now, this is the question. Everybody understood till here? We need to solve this 2-3 questions, previous year questions, then we'll exactly move. Then we'll get done with this. Come on, I need to know in the live chat. Give me some signals. Yes, sir. Let's solve this. And all of you, before you leave, like the lecture, okay? Okay, let's solve this question. J means 2019. So stream of river has velocity 2 km/h. Stream can swim with, swimmer can swim with 4 km/h. Okay. And so basically it is saying that this is a river. It is having the velocity of V is equal to, that is 2 km/h. Okay. This is the velocity of water, velocity of a river. We'll say velocity of water. Okay. And swimmer can swim with 4 km/h. Understand? This swimmer can swim with 4 km/h. It is having, the swimmer is having the speed of 4 km/h. Find the direction of swimmer so that he travels straight with the flow. Understand? Find the direction of swimmer so that he travels straight with the flow. Understand? We need to basically find the direction of swimmer, in what direction he has to travel straight. Understand? So this is not the correct English that the PPT person have mentioned. Okay. So what is the exact question? I'll just make you understand. So this is the velocity of water over here. And if I say, for example, the swimmer has to cross the river straight. Understand? Straight. Understand? He'll cross this river like this only. Okay. So it is saying that he has to cross the river with the shortest path or with the straight clearly. So at what direction he needs to basically move with respect to this flow, not with this. We need to find basically that angle. Understand? With this one. So this is basically the direction of flow. This is direction of flow. With this direction of flow, what should be the angle so that he should move straight from this point to this point? That is the exact question. Okay. Let's solve basically this. Kritika is saying, see, that's great. Okay. Now see how we can solve this. If I say, for example, he has to travel straight from this point to this point. So he should basically travel, he should start at some angle initially, because then only he will be basically dragged and it will basically, he will eventually reach over here. Can I say in this case, clearly this Vs, if I say this is Vs and this will be Vs cos of theta and this will be Vs sine of theta. Okay. Vs cos theta, this is Vs sine theta. So, and this will be nothing but a Vw. If he has to travel from this point to this point straight, so in that case, this Vs sine theta has to be equal to Vw. Means that this velocity has to be equal to this velocity, because they will kill each other and he will travel through this path with this velocity only. Now, in this case, we need to use only this one, we'll get the answer. Can I say in this case, Vs cos of Vs sine of theta, Vs sine of theta is nothing but V of W. This will be equal to this one. So in this case, sine of theta is nothing but a Vw of Vs 100%. Now you tell me one thing over here, that is sine of theta. We need to find the theta only. Vw upon Vs. How much is Vw? That is a 2 upon Vs is how much? This is given as 4 km/h. He can swim with 4 km/h. This is 4. So it will be 1/2. 1/2. So sine theta, value of sine theta is 1/2 when theta is how much? I guess 30 degrees. Okay. So this is 30 degrees. Now, is the part option A answer in this case? Definitely not. Why isn't the option A answer in this case? Because we need to find the direction of this swimmer, how, at what angle he should basically swim in order to reach from this point to this point with respect to flow. So we need to basically find this angle. I call this as alpha. Can I say this alpha is basically equal to this 90 plus this theta? Theta we already got. Alpha is nothing but 90 plus this theta. So alpha is nothing but 90 plus 30. It will be equal to 120. So option C is 120. Yeah. Come on, let's move on to the next question now. This one. A boat has speed of 5 km per hour. Understand? In water. A river of width 1 km long. In a river of width 1 km long along the shortest possible path in 15 minutes. The velocity of water is. What is he saying? See, it is saying that this boat has basically traveled from this point to this point. Understand? So he already might have basically moved at some angle initially. I would say, for example, that what? That is this theta. So he has traveled through the shortest possible path in how much amount of time? Time is basically given. So it's saying that a boat has basically crossed this river in how much amount of time? That is 15 minutes. If I convert it to hours, I can basically write it. T is equal to 1 by 4 hours. Okay. So the width is basically, this width is given as 1 km long over there. And a boat has a speed of 5 km per hour. It is saying that velocity of this boat is nothing but 5 km per hour. Okay. This is basically the velocity of this boat. So we need to basically find what is the velocity of a river. It is dragging it towards this. So velocity, river will have some velocity of river. That is what we are supposed to find out over here. Can you tell me what is the answer of this one? We need to directly use the formula that I told you previously. See. This formula. Understand? See. Same question over here. In this case, this is a case crossing the river by shortest path. So if we need to basically travel in the shortest path from this point to this point, we already have to move at some angle. Understand? If we move at some angle, we'll travel through this velocity because this velocity will cancel this velocity. So eventually we will basically travel through this velocity. How much time it's gonna take exactly? That is T upon this Vs cos of theta. T is equal to D upon this Vs cos of theta. How much distance it is, how much velocity it is. And already we got the Vs cos of theta equal to how much? That is Vs by, after doing this much of simplification, Vs square minus Vw square. So we can reuse this formula, we'll get the answer. So D upon, so can we use this? T is equal to D upon root of Vs square minus Vw square. Yeah, Vs square minus Vw square. Now you tell me one thing, how much the time over here? That is 1 by 4. Distance is how much? That is 1 km long. And the root of velocity of swimmer or velocity of boat, how much? That is 5 square minus velocity of water square. That is what we need to exactly find out in this case. So can we just do one thing over here? So take this root over here. So we can write this is 16 is equal to, this is nothing but 25 minus Vw square. So Vw will be nothing but, this is 25 minus 16. It's a root. So Vw will be exactly, this will be a root 9. So it will be 3 km per hours. So option C is the correct option. Option B. Okay. Fine. Now this is the another one we have on the screen. A river is flowing from west to east at a speed of 5 meters per minute. Okay. A man on south bank is capable of swimming at 10 meter per minute. He wants to swim across the river in the shortest time. Okay. Fine. This is the case. So basically, the person wants to cross this river in the shortest time from, if I say this is south and this is north, he has to go from south to north. Okay. This was the question asked in IIT JEE 1983. So he has to travel from this point to this point in the shortest time. So the options are given. He should swim in the direction of due north 30 degree east of north, this, whatever it is. Now, simple case. Previously, I have told you for shortest time, what is the formula? That is d upon Vs cos of theta. This is basically the general. So for shortest time, theta has to be equal to 0 degree, because this will increase, this term will increase, and this will decrease over there. Time will basically decrease over there. So theta has to be equal to 0, cos 0 will be 1. This cos 0 will be 1 and this will be maximum. So can I just write, it will be nothing but d upon Vs. Exactly means you have to use whole of your velocity along this only, Vs only. So in which direction he should basically move? He should start moving. So we measure the theta with this one only. Understand? So theta with this vertical only. So it's saying that theta is equal to 0 degree when you move. Time will be basically minimum. Time will be minimum if you move theta is equal to 0 degree from this point to this point exactly. Now can you tell me, so which option should be correct over here? Clearly due north. You have to move along this direction only towards the north. You can definitely reach it in shortest time. Yeah. So this was all about it, ladies and gentlemen. Fine. I hope everybody understood this. So, and most importantly, I need to tell you guys that JEE Mains 4th attempt paper solution is going on right now inside Unacademy. Okay, the link is in the description below. You can definitely visit. Check that if you want to basically solve the papers with our educators. So it has already started from yesterday itself. Everything is clear. Come on, I need to know in the live chat. And how can you enroll in our special classes? Because special classes are completely free. Tomorrow, I suggest you to come and join our special classes exactly at 6 o'clock. Okay, 6 p.m. special class, Unacademy. Special class. And in that special class, we'll be solving the problems on this today's topic, previous year questions. What is it? Whatever it is. So basically, you can download the Unacademy app in order to come in our special classes and log in with your number. And you can search me over there. There is a search bar. You can find me. This is my username. When you get my profile, click on this special classes, click all. And whatever the special class is, upcoming class, you can click on that one if that is, and when you press this play button, it will ask you for a code. Use this code, you can definitely enroll. That's completely for free. And recently we have launched this batch in Unacademy that's completely in English language. If you want to boost your rank, this is for 11th JEE Mains and Advanced 2023. So some of the top faculties are teaching you from different states in these batches, and this is the Shine batch, which is there you can basically learn from some of the top Telugu educators. This is for class 12th JEE Mains and Advanced. You can definitely enroll in this one as well in order to boost your rank. Now, apart from this YouTube platform, we have our own platform. That's the Unacademy's platform. Over there, you'll be getting, you can basically take this plus subscription. You can take this Iconic subscription. So these are the benefits you get in plus subscription, like live classes, structured courses, weekly tests, unlimited access. And in this Iconic subscription, you'll be getting all the benefits you get in plus, and this personal guidance, test analysis, experts guidelines, study material, study planners. Okay, so these are very important. If you want to boost your rank in your upcoming JEE, I suggest you should go for it. Okay, and this is my username on Unacademy. You can definitely search me over there and follow me over there, because we come up with lots and lots of special classes, everything. And this is the IIT JEE Iconic subscription. If you take it for 12 months, 18 months, 24 months, you will be getting the branded notes that will be delivered to your doorstep. And if you take this plus subscription for like 12 months, you'll be getting 2 months of extension. And for 24 months, you'll be getting 2 months of extension. And if you take this plus subscription for 12 months, the price will be for this. And if you want the maximum possible discount, I suggest you to use my code. Okay, use my code only. Okay, the people who are really looking for joining the Unacademy Plus and wants to learn from us in Plus, they should definitely enroll in this one. They should definitely take the Plus subscription by using my code. So you can definitely use my code. This is for the price. This is the price in order to get the maximum possible discount. And it is for 3 months as well as 6 months. The EMI options are also available. Okay. And then comes the Iconic subscription. You can take it for 12 months, 18 months, and 24 months. By using my code, you can get the maximum possible discount. This is my code. Okay, this is the price for 12 months. This is for 18 months. This is for 24 months. You can use my code in order to get the maximum possible discount. So this is the IIT JEE Combat Scholarship Test. Previously, it was on 22 of 2nd. Now, bye. Now it is on 29 August. It is exactly at 11 a.m. 60 questions will be asked. 60 minutes will be the time, and 21 questions will be asked. These are the prices that you're gonna get, and you can win up to 4 crore plus scholarship. And if you find any of my content as inappropriate, you can definitely report. The link is in the description below. Thank you so much, ladies and gentlemen. Before leaving, you should subscribe to this channel. You should hit the bell notification, like this video, and share this video. And most importantly, comment on the video, whatever you liked about the video. Thank you so much. It was all nice interacting with you. Okay. Chill. Take a chill pill. Bye-bye. See you very soon tomorrow at 6 p.m. in the special